I'm glad to be here. I'm glad to be invited to talk a little bit about innovative R&D and how innovative R&D can help improve how we do security testing, especially in the DevOps world. As one of my PIs, Marone Livney, who is sitting here today this morning, would say, do it early and do it often, through an approach known as continuous assurance. We must continue to emphasize the need to shift left, building a pipeline that includes the security attributes, mechanisms needed to find and address security issues in software development at speed. I want to talk a little bit about innovative R&D. One of my goals I aim to achieve with and through my software assurance R&D program is successful tech transition, meaning getting technologies in the hands of folks who can operationalize it in their environments. For the last 5 years or so, I have been actively engaging the community, government, industry, and academia to better understand the gaps that exist in state-of-the-art software assurance tools and capabilities. My program at S&T exists to push forward the state-of-the-art and the state of practice to increase the adoption rate in the software development community. I discovered and observed some interesting things in the last 5 years or so, all of which helped shape and influence my approach in aligning my R&D program. I consider these my 10 observables in software assurance. So I want to talk about 10 things that I observed that help shape and align my software assurance R&D program. Number one, the state of practice is lagging. There is no standard way to measure and baseline how well software assurance tools perform. We don't know what tools can and cannot do with some certainty. The OWASP Top 10 lacks the foundational science to advance AppSec practices in organizations, specifically as it relates to the methodology for data collection and data analytics and formulating the OWASP Top 10. As Brian Glass from Invisium points out in his blog, musing on the OWASP Top 10, 2017 RC1, and I quote, "The metrics collected for the Top 10, 2017 represent what was found by either tools or time-box humans. It's a subset of vulnerabilities that are typically found, but are probably not representative of what is actually out there or the bigger risks that are faced," close quote. There's a lot of room for improvement, and I believe with the next release, the release candidate 2 for the OWASP Top 10, and more community involvement, we can advance the Top 10 to beyond its intended purposes to have a greater impact on advancing AppSec practices. NIST 853, too network-centric system focus. There are security controls with software assurance applicability not included in any of the system baselines, whether it's high, moderate, or low. Which means these security controls that have software assurance applicability are not being tested as part of the certification and accreditation process. Secure coding practices are missing in action and are not being enforced religiously in AppSec programs. Number two, threat modeling, when automated, is very powerful. There's a lot of potential leveraging machine learning with threat modeling that can be used to take a more proactive approach to software development that can help improve security designs and reduce overall security risk. I believe threat modeling will eventually become the core engine in all security testing. Number three, there are residual risks in using static analysis and security testing tools. We don't know what tools did not find. We don't know what parts of the code and attack surface the tools were able to cover. Static analysis struggle with opaque code, essentially code not analyzable by static analysis. Static analysis tend to be shallow and oversimplified. And when they're shallow and oversimplified, they miss things. Heartbleed, we're all familiar with Heartbleed. Heartbleed won against all static analysis tools and many other dynamic analysis tools. Number four, false positives, the proverbial pain in the rear end. I mean, we all can attest that false positive creates a lot of work and is very painful for what we're trying to do to develop software at speed. Many vendors rather err on the side of caution and tell you something is there that is not there. rather than tell you something is not there and is actually there. Tools lack context. To be sound, meaning having a low false negative rate, there's a trade-off that will generate a considerable amount of false positives. This is the interesting trade-off with static analysis. Number 5, patching does not scale. I'm going to repeat that again. Patching does not scale. Software assurance, secure coding must, should be, it has to be our first line of defense in protecting software. Software assurance, secure coding must, it has to be our first line of defense in protecting software. The window of exposure is constantly sliding to the right. Human and social behaviors play a part because people resist change. People become the Achilles heel in the software engineering process. Cybersecurity expert Dr. Diana Burley, professor of human and organizational learning at George Washington University, credits in part, and I quote, "The rise of cyber attacks to the failure of the average computer user to take preventive measures like patching. IoT and IoE is proving that patching is becoming a lot harder for many different reasons, like safety. And I think we have over 465,000 reasons, in addition to 143 million reasons based on recent events, why patching does not work. Number 6, poor tool performance creates barriers for tool adoption by developers early in the software development process. I often wonder why commercial tools and open source static analysis tools struggle with NIST and NSA's Juliet test cases. Juliet test cases were developed by NSA and essentially artificial code that comprises of C and C++ and Java test cases. NSA did a tool study, and the tool study suggested, on average, that a given static analysis tool can find somewhere in the neighborhood of 14 to 17% of actual weaknesses that were in the Juliet test cases. Some open source static analysis tools did just as good, and in some cases better than commercial ones, on certain weakness classes and programming languages within Juliet. Number 7, there is no Uber tool. The sum of many is better than the sum of one. I'm going to repeat that again. There is no Uber tool. The sum of many is better than the sum of one. Each tool has a sweet spot. Too many programming languages and weakness classes for one tool to be a jack of all trades. Different testing methods find different things. I am seeing a movement that is encouraging the use of multiple tools for security testing. I just recently became a member of a technical committee initiated by Microsoft developers to push for a standard to format and to incorporate multiple tools and outputs. So now they're coming up with a specification for output where all vendors can design and have their tools for a standard output. Now this is Microsoft who's leading this charge. Number 8, more code equals more problems. New cars today have at least 100 million lines of code. That's an increased attack surface. Sensors everywhere on the cars. Often more features means more code, and more code leads to more complexity, which tend to lead to more problems. This is what software engineer Brian Knapp referred to as software gravity, the force that pulls features, complexity, and resources towards a software system over time. Number 9, technical debt increases the cost to maintain software. Many organizations have no clue as to how much technical debt has been accumulated. Many take shortcuts, which leads to poor design decisions that will ultimately create vulnerabilities. Design debt, testing debt, and defect debt all contribute to the cost to maintain software. And finally, number 10, foundational science is a key to forward-leaning capabilities. If we're not exploring, we are not advancing the state of art. I believe that achieving security at speed is very important, but it's also difficult to achieve in the current landscape. It requires an approach that leverages a diverse set of security testing techniques and methods, best of breed, to cover and test as much of the attack surface as possible. The goal is to find security vulnerabilities that matters the most. This is a force multiplier. Nevertheless, innovative R&D is a true enabler for achieving security at speed. I approached my research with this in mind. I look at R&D from two perspectives. The first perspective, modernize technologies and capabilities that currently exist to make them better and more efficient. Second, innovate to close the gaps that exist in state-of-the-art and the state of practice. There are three areas of security testing that I believe require some novelty and advancements. These three areas are 1, static analysis, 2, threat modeling, and 3, red teaming and pen testing. I want to share with you briefly some of the work DHS S&T is doing around these three areas to support and empower the DevSecOps movement. The realization that static analysis tools have not kept pace with modern software development is a strong motivator for me to invest in advancing the state of the art. This has led me to create a program called STAMP, Static Tool Analysis Modernization Program, designed to modernize open source static analysis capabilities, especially when people are asked to do more with less. I can recall several years ago, I was sitting on a couch watching HGTV, yes, HGTV, with my wife, and we were watching the Property Brothers. How many are familiar with Property Brothers? So I had an aha moment. So Property Brothers is two brothers, one finds neglected homes, and then there's another brother who takes the neglected homes, infuse money into neglected homes to renovate them. I said, aha. I said, I want to do the same with static analysis, open source static analysis. I said, I want to find neglected static analysis tools that make sense across all different programming languages, whether static or dynamic programming languages, and I want to infuse some R&D dollars in it to innovate them. Raise the bar of these tools to make them as good or even not better in some areas, because there's no Uber tool, but make them as good as some of the commercial grade tools. So I came in the next day and I started writing out what STAMP will be about. So STAMP essentially has 4 major components. 1, evolve test cases, so we have a way to test and measure tools. 2, we needed to test the tools and run some tool study to figure out what the tools are really good and not good at. 3, we want to modernize, use the testing tool study to figure out what our modernization framework is. And 4, educate the community about the strengths of the tools so that when you want to go use a static analysis, you can find the right static analysis tools that meet your software development needs. So that's how STAMP came about. STAMP will accomplish 2 important things. Increase the adoption rate of using static analysis early and often in software development. 2, lower the bar for organizations to formalize software assurance in their environments. As part of STAMP, I want to explore why static analysis tools struggle with simplistic test cases like Juliet. I recently asked one of my PIs, Dr. James Hill, who is a computer science professor at IUPUI, why is this the case with static analysis on simplistic and small test case suites like Juliet? He provided a very interesting theory in response, and I quote, he said, static analysis tools struggle with Juliet mainly because static analysis tools make assumptions about state. If you look at how Juliet is constructed, it's composed of deterministic flaws and incidental flaws. Deterministic flaws, from what we are learning, are the ones that I would consider to be discernible by analyzing the current file. The incidental flaws are the ones where the flaws exist within a specific context. Many times, this context is not local to a current file. Unfortunately, many static analysis tools only look at the current file and the include files, which do not contain any analyzable context, especially in the C and C++ world. The important contextual information, such as the values of parameters to a function call, are not known. This is where assumptions are made and false positives are generated. So I want to talk a little bit about some of the innovative things we're trying to do through STAMP with static analysis. Develop techniques to recompose static analysis on the fly as needed to suit program conditions, matching program features with static analysis features. Studies from NSA, NIST, and the ones I've sponsored through my program have shown and proven that tools have narrow sweet spots and are good at certain things. This type of framework will create a verification workflow that will help developers use the right tools to test for specific problems in their code by exposing the properties and behaviors of static analysis to the developer. Next, reduce the mean time to repair or remediation by making verification results more directly relevant to the program source code, preserving the context and helping the developer better understand the implications of tool results. Next, improve the detection of incorrect API usage that could expose security flaws or security bugs in software. Develop techniques and methods to look for the correctness of API usage given the increased demand of frameworks used in modern software development. Next, improve analysis workflows by standardizing an interface for tools such as verification generators, theorem provers, model checkers that can be used in the CI/CD pipelines to orchestrate better automation around static analysis tasks. Next, develop the next evolution of test cases that represent real-world programs. By using evolutionary computation to produce a large collection of programs with known bugs to estimate recall in static analysis tools. Recall is defined as the number of real flaws reported divided by the total number of real flaws, whether reported or unreported, that exist in code. Evolutionary computation will help customize the distribution and features of bugs. This will help improve the state of practice by providing a way to measure, baseline, and benchmark static analysis tools and capabilities. Next, develop capabilities that identifies and signal false positives in tools by leveraging big data analytics to increase the confidence and certainty. I envision this capability working in the CI/CD workflow to filter out false positives, but increase the confidence in true positives, helping developers to focus on those security vulnerabilities that matters the most. Now we're going to talk about threat modeling, what we're doing around threat modeling. I think it's important to mention understanding ways in which your application or system can be attacked is an essential part in developing, designing, and building secure systems, especially in an automated way. SafeCode, in their Tactical Threat Modeling white paper, echoes the following, and I quote, "Threat modeling is a core activity and a fundamental practice in the process of building trusted technologies. It has been identified as one of the best return on investment activities with respect to identifying and addressing design flaws before their implementation into code. Application security, threat, and attack modeling, also known as ASTAM, is another important project that I have with two technical areas focused on modernizing and innovating capabilities to help achieve security at speed. I want to talk about automated threat modeling that we're doing as part of ASTAM. We're automating threat modeling capabilities that leverages machine learning to identify risks and threats to the underlying security architecture. We're leveraging architecture synthesis to discover features and how those features are implemented in code, with the ability to detect architecture erosion. We're connecting threats to root cause, mitigation techniques, and software requirements to help organizations build security in with automated threat generation. We're prioritizing remediation efforts and guide security testing to areas with architectural significance, which helps us to be more focused in our security testing. So we're not just testing things that are not important, but we're testing things with architectural significance. We're leveraging CWE, Common Weakness Enumeration, and CAWE, which is Common Architectural Weakness Enumeration, to introduce architectural-centric thinking into developers' daily activities that informs developers about the consequences of their coding practices and refactoring activities that erodes the architecture and design of a system. The CAWE work was funded through my program and is currently being integrated in the next release, the 3.0 release of CWEs that MITRE has adopted as part of the next release. And I believe MITRE mentioned that it should be available sometime this week. So be on the lookout for the CWE release 3.0, which will have the common architectural weakness enumerations overlaid in there to help developers better understand the design and architecture implications of software development. Consider the recent issue involving pacemakers, where 465,000 patients needed patches. Many reference this to an episode from Homeland that demonstrated the plausibility of hacking pacemakers. Can you imagine ransomware targeting pacemakers? Well, Matthew Green, a Johns Hopkins University professor specializing in cryptology, is among the people arguing that this threat is real. This is where automated threat modeling can be used to identify these type of threats and risks to inform manufacturers of how to improve the design, the security, and safety of medical devices. In addition to automated threat modeling, the second technical area for ASTAM we're developing involves automated pen testing activities. We must take a proactive approach to security testing and have capabilities on demand to mimic an attacker's behavior. So I want to talk a little bit about automated pen testing capabilities that we're developing. So we have a tool that has been developed through a previous program that I have sponsored as part of our broad agency announcement 1102. This was a program that I initiated coming into DHS back in August of 2012. The name of this tool is called Code Pulse. It's currently an OWASP project. We are going to, right now it has Java support, we're extending it to .NET. And what Code Pulse does is provides real-time coverage for penetration testers who use either manual or automated pen testing tools to understand the extent to which their testing activities covers the breadth and depth of a web application source code, and provide a visual-rich interface to help guide more in-depth penetration testing. So having the ability to understand when you're doing pen testing, what parts of code or what part of the attack surface that you were not able to cover, and visually be able to see that is very important, so that we can really cover testing and understand what additional methods we need to use as part of our testing. Hybrid analysis with SAS and DAS to improve tool coverage. Use source code to calculate the attack surface in web applications, and inform DAS tools to make DAS tools more smarter or increase the coverage that DAS tools will have by leveraging SAS to feed into DAS to increase the attack surface. That will help us improve and increase our ability to test more within the application. We need to see the entire attack surface, even if it's not called during execution. This will allow for more guided, more efficient testing. DevOps engineers and security teams can track changes to attack surface for more focused DevSecOps. We also been building a penetration testing automation framework. In a DevOps world, there's no way for organizations to keep up with manual pen testing. Creating an automation platform for pen testing is the key to scaling pen testing during the development and testing phases of the SDLC. With this pen testing automation framework, we're leveraging threat modeling to enhance and guide penetration testing to attack surface areas that may be exposed. The pen testing automation platform leverages enhanced versions of SQL Map and Hydra. So the enhanced versions of SQL Map and Hydra has been developed through, the enhancements has been developed through the ASTAM program. So we can test for SQL injection and weak passwords. But also, we're going to extend these both for automation into the CI/CD pipeline. We also have developed a cross-site scripting capability that's more surgical and precise, focusing on detecting reflective attacks more intelligently. The pen testing automation framework is extensible and will be available for the community to share and collaborate around attack libraries. I want to talk a little bit and shift gears and talk about the software assurance marketplace, the SWAMP. In a recent survey conducted by HP Enterprise on DevOps, it revealed that 90% of surveyed organizations are implementing or piloting some aspect of DevOps. But there's a caveat. However, only 20% only 20% surveyed are actually doing AppSec testing during development. This is not only alarming, but can speak to something that my colleague Arthur Hickens of Parasoft emphasized, and I quote, DevOps presents opportunities to create vulnerabilities at a faster pace, which he refers to as vulnerability acceleration or velocity. One of the benefits of the swamp is to lower the bar for organizations to formalize software assurance capabilities and practices in their organizations. Tool experts, computer scientist Bart Miller and his team at the University of Madison, Wisconsin, handle all the plumbing and configuration of tools for you. Today, the swamp consists of 20 plus open source static analysis tools, as well as commercial tools, visual workflow analysis, multiple platforms to run analysis, and over 500 software packages and test cases to be used to test your tool capabilities. The swamp is the growing realization that you need to use multiple static analysis tools to analyze software for weaknesses that expose vulnerabilities in software. But also, it's the realization that continuous assurance is one of the underpinnings for improving software security development. The SWAMP team has translated this concept into a framework that brings together multiple tools and high throughput computing automations in a managed environment that combines with continuous integration, program development environments, and federated identity management. This framework has been implemented in a portable open source platform called Swamp in a Box. Swamp in a Box is an open source and is currently on GitHub. So one of the things I've always wanted to achieve, and I mentioned earlier, is lower the bar to transition technologies to the development community, make it easier to formalize software assurance in software development environments. So I'm going to talk a little about the swamp and the benefits of the swamp. The swamp promotes the idea of continuous assurance by providing a platform that reduces the barriers for developers to integrate continuous assurance practices in their CI/CD pipelines. The versatility of the swamp framework will allow for dynamic analysis, software composition analysis, and eventually some forms of threat modeling. APIs, automation, and computing capacity offered by the swamp support seamless integration with DevOps workflow, easily integrated with CI/CD tools such as Jenkins, Eclipse, and repositories such as Git and SVN. Swamp plugins for Git and SVNs can pull from repositories to easily start assessments in the swamp. Or a post-build action can be created in Jenkins to start a static analysis assessment. Results from the assessment can be viewed in the swamp or the native IDE for easier and quicker triage. Developers and researchers have the option of bringing in new tools and capabilities into the Swamp in a Box platform, or leverage the swamp's rich APIs to hook in commercial tools and assessment workflows. So if you currently have investments in your current static analysis capabilities, the Swamp APIs provides a way to hook those into the Swamp in a Box platform, allow for easier transition of your current testing environment, what allows you to get your return on investment of your existing investment tools. The modernized static analysis tools from STAMP, as I talked about earlier, will be under the hood in Swamp in a Box, providing the development community with powerful assessment platform to achieve security at speed. With the Swamp, there is no reason not to formalize software assurance. In closing, it was important for me to highlight the contributions of DHS S&T in leading innovative R&D to support the DevSecOps movement that has become embedded in many cultures and in many organizations. Our role is to lead and transition R&D to operational environments. We all can agree that software powers not only critical infrastructure, but our daily lives. We all have experienced the effects of bad software, from medical devices to Equifax, to Home Depot, to OPM, the list goes on. As a result, we must continue to look for ways to close the gap that exists in the state of the art and the state of practice to keep pace with modern software development. Innovative R&D and forward-leaning technologies provide a pathway to help achieve security at speed. Industry, academia, and government must partner and collaborate to work on addressing the challenges we face with building security in. Building security in is more than just a catchy phrase. We must adopt it as our philosophy, our mindset, to emphasize the need to think about ways software can be attacked during all phases of the software development process. I'm excited, and I believe the future is bright. I see potential in leveraging machine learning where applicable to advance the foundational science in the areas of software assurance that allow us to bring to market and operationalize innovation like the work from DARPA's Cyber Grand Challenge with machine coding, automated patching, fully automated security pipelines, and self-healing software. We are not far off. Stay the course, and always, and I mean always, think DevSecOps. I thank you for your time. I have some time allotted, and I'm going to take a couple questions if there's any questions. I would like to take some questions. If there are any questions?
Where I struggle is that spending time and resources to adopt a government-supported project, program, what have you, puts me at risk. Because if the government chooses to either lose funding to support that program or take a different direction, I've advocated for the use of this government-sponsored program, and I've convinced the company to make investments to move in that direction. If that now pivots away, I'm in the bag, and I've burned a lot of political capital driving towards that government platform. And so I was wondering first if you could talk about the horizontal view for STAMP, I believe, and if you could share if you could give a rough level of confidence, especially with the new administration and funding and priorities, if you think we're going to really drive that program.
Thank you for your question. I can't really talk about budget, so I'm going to stay away from any questions that's involving budget. But one of the things I do with my program, I try to leverage a number of sort of different things. One, currently my portfolio consists of academia, small business, and individual researchers. So for STAMP specifically, I have 2 performers. And eventually I would down select and have 1 performer. But I'm going to let you know a little bit about the 2 performers. One of the performers is Grammatech. Grammatech is a commercial company that has a static analysis capabilities. The other company is Kestrel Technologies, who has a track record of doing great R&D and has technologies they have developed. And some of the technology has been developed in my program. They have a static analyzer called CodeHawk, which is a very sound static analysis tools that mathematically prove code locations are safe from memory safety type vulnerabilities. So leveraging those 2, and let's say eventually I have a down select, I see the pathway to commercialization. One of my biggest things, if anything I fund, I haven't had a clear understanding of commercialization. So before I come up with a topic, even if I get a white paper or some type of proposal, I start from the end and work my way back. I need to understand use cases. I need to understand potential stakeholders. I need to be able to have a good understanding of how those use cases can be operationalized so that we can increase the adoption rate and really remove the barrier for tech transition and commercialization. So that's one. Because we are developing these tools as open source, there are already some communities with some of the tools that were selected. I'm not going to necessarily get into some of the tools. Each performer selected whatever tools they wanted, the candidate tools. So essentially, there were a list of candidate tools they selected. And it crossed Java, Python, You know, one of the goals of STAMP really was, listen, dynamic programming languages are on the rise. If you look at some studies, they are some of the more popular programming languages that are being used. So I wanted to also have STAMP focus on some of the dynamic programming languages. And some of these open source static analysis tools already have communities. And if you look at it from Grammar's Tech perspective, the stuff that they're developing, I potentially see a pathway into their flagship product, which increases the adoption rate. So from my perspective, if I fund something, I want folks to use it. I want to get the stuff in the hands of folks. And I want to increase the chances of doing that. And commercialization provides a unique way to do that. So hopefully I answered your question. Any more questions? Okay, thank you for your time. I appreciate it. Oh, one more. Yes. Can you stand and say your name?
I'm Lauren Bell. How current are the Juliet test cases, and how much are they being used as a frame of reference for public static analysis tools now?
So Juliet, I believe, was developed somewhere around 2010, I believe. So every year, NIST, or every other year or so, NIST has a program called SATE, Static Analysis Tool Exposition, where they reach out to the community, whether you are an individual tool developer or you're a commercial tool developer or open source, and they have a tool study called SATE. And part of it is they use Juliet as well as some other data sets as part of this. One of the biggest arguments, and I've learned a lot from working with NIST and other government agencies, one of the biggest arguments, as I alluded to in the talk, is that many believe that Juliet does not represent real code. It's artificial, it's synthetic, small test cases. And I said, if we're going to really advance the state of the art, we need another evolution that represents real programs. So Juliet is currently being used, but a lot of commercial guys don't like using Juliet because of that simple fact. So one of the questions I pose to my developers, why do tools struggle with Juliet? Juliet is very simplistic. So that's one of the questions that we hope to answer with more certainty with the SWAMP program. Why are tools struggling? If I'm a commercial tool and I claim I can handle complex code, why do I struggle with very simplistic code? I mean, there are some thoughts about it, but I think foundationally, from a foundational science perspective, I want to prove or disprove that. Because I believe if we can have more information and more certainty around that particular problem, it potentially opens a pathway to innovate and modernize around static analysis. Hopefully I answered your question. One more question.
Yeah, Fred Cohn. Quick question. You mentioned automated threat modeling. Do you see a tool-based automated piece that will end up in the design chain that will, in a sense, is that what you mean by automated threat modeling?
Right. So as part of the ASTAM project that I talked about, we're building an automated ASTAM, Application Security Threat and Attack Modeling. It's a program that I have as part of my portfolio at DHS S&T Cybersecurity Division. We're building an automated threat modeling capability now. And I think, and as I mentioned in the talk, I believe threat modeling is going to be a core part of all security testing because it has the intelligence to guide testers to parts of the attack surface or parts of the code or system that have architecture relevance. And where the architecture is, usually is where your security patterns are part of the design. So if we can guide folks and use static and dynamic and pen testing tools to guide them to areas that needs the testing based on the threat modeling and the risk and things we identify, I think we're doing a better job. Because today, we get a bunch of false positives. We don't know what to triage. That's part of the problem, right? So I think if we can provide that capability, I think we can have a more focused, more guided DevSecOps in terms of testing, which will reduce time and help developers work faster and work at speed.
Can you just repeat that acronym one last time?
Application Security Threat and Attack Modeling. I call it, in the government, you know, there's acronyms for everything, right? So we call it ASTAM. ASTAM. And it was a broad agency announcement. And if you Google ASTAM, Application Threat and Attack Modeling, go to fbo.gov, you'll find information on that project.
Great.
So in terms of finding out this information, I found standard and not swamp the box, but is there like a stamp, is there like a, if you want to learn more about it, where do we go?
So, two of my performers are here. Secure Decisions, who's the lead PI on the ASTAM project. Chris Horn, can you raise your hand? So Chris has information on ASTAM. Swamp in the Box, Marone Livney here, has all the information on Swamp in the Box. And I appreciate you guys coming today to join us today. So I think with Swamp in the Box, you mentioned you found it already. With ASTAM, we're looking to have something that can be on market, to the market, sometime mid-April of next year. And as always, we're looking for pilot customers, folks who we can demonstrate some proof of concept, some level of an MVP, and potentially look for someone to be transition partners so we can transition to them. One more question, I think you right here.
Any preference regarding threat model?
I don't have a preference. I think what we're doing, we're going to leverage kind of both to a certain extent. I don't think there's a right or wrong in terms of approach to threat modeling. But one of the things we do is we're taking a different approach and we're focusing more on the architecture side, because one of the things that we do have to do is we have to start getting the developers to think about the architecture and have it in their daily activities so that we can prevent architecture erosion. So security features that has been defined as part of the architecture can be implemented correctly in code. But to do that, I think developers need to have an understanding of the architecture so they can implement and enforce security features properly in code. All right, I think my time is up. Thank you. Thanks, everyone. Enjoy the rest of the day. Enjoy Boston. Thank you.